Welcome. In our previous video, we introduced the basic syntax of the SQL select statement. We noted that this statement is used to retrieve data from a relational database table. In that video, we discussed the concept of a predicate, and we showed how a predicate could be included within the where clause of an SQL statement to target a specific set of rows. In this current video, we'll continue our examination of simple data retrieval, and we'll do this by addressing some interesting topics. Specifically, we'll consider how duplicates might appear within the result set of a query and how we can remove those duplicates. Because it's often necessary to work with records that are sorted in some way, we'll discuss how this can be accomplished using SQL. When the list of columns being returned by a query does not include any of the unique columns, say the primary key, there's a possibility that the results set could contain duplicate rows. Let's consider the following query. The objective of this query is to identify the departments that currently sponsor courses. So we're selecting the C department column from the course table. The result will contain duplicate rows because a given department may sponsor many different courses. Furthermore, the system does not automatically remove these duplicate rows from the result set. Before we get into the details of this duplication and the removal of the duplicate rows, let's take a closer look at just what's going on with this query, because it's interesting to discuss. So aside from the issue of duplicate values, it's very important to consider the objective of this query. That is, the purpose of the query is to identify departments. However, the query is targeting the course table, which contains course data, not department data. If you consider the contents of the department table, there's no indication of which departments sponsor courses or employ faculty or so on. It's just a set of facts about the department. So information of this sort is the result of relationships that are captured within a database. That's the purpose of the C department column. It serves to capture the relationship of a department sponsoring many courses, or a course being sponsored by one department. It's a foreign key that represents the one-to-many relationship between these two tables. That's the column from the course table that we'll be examining to answer this particular question. Let's take a closer look at the course table and the output for this query. As we noted, there are many instances of the same value. The output will consist of 14 rows of just the one column C department. So how do we go about removing these duplicates? After all, if someone asked you which departments sponsor courses, you wouldn't want to respond and say philosophy, 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 and repeat the value of a department name as many times as there are courses. So how do we remove the duplicates? It's actually quite easy. We simply insert the word distinct immediately following the select keyword and before the columns that are being selected. The output of this modified query will have no duplicate rows because of the presence of the distinct keyword. Now, what constitutes a duplicate? Well, two rows are considered duplicates only if every column in the resulting row matches every corresponding column in the other row. Here, our rows are in the result set and contains simply C department, a single column. So if we see 4 rows in the result set that all say philosophy, then we'll retain only one of them. We'll talk about what happens when you have multiple columns in just a moment. So the distinct keyword prevents the duplicate rows from being preserved in the query result. Note that distinct is positioned immediately after the select keyword, separated by 1 or more spaces, and then following distinct, again 1 or more spaces, then your column list. In the next query, we're going to select rows and display multiple columns. The result set will consist of rows that have a C department value and a credit value. So the output of this query will consist of C department and credit for those courses with a lab fee less than 100. Now, because we're selecting multiple columns, the likelihood of getting duplicates is reduced, but not completely eliminated, because neither C department nor credit qualifies as a unique type of column. There are no unique constraints on these columns. So it is possible that duplicates can be produced by this query. If you examine the output of the query, you will see that there are duplicate CIS rows and duplicate theology rows. The 2 philosophy rows are not duplicates because they have a different value for credit. The duplicate rows displayed by this query can also be eliminated using the same technique we discussed just a moment ago, simply inserting the distinct keyword within the query, again immediately following the select keyword and preceding our list of columns. Now, although the query contains multiple columns, the distinct keyword can appear at most once within a query. So it would be incorrect to say select distinct C department, comma, distinct credit. We use distinct exactly 1 time. Here we present the modified version of the previous query, showing the correct use of the distinct keyword. The effect of that keyword is that those rows that contain the same value in C department and credit will be considered duplicates, and only 1 instance of that row will be preserved in the output. In the queries that we've run up to this point, the names of the columns in the result table were determined by the names of the columns being selected from the database table. Hence, when we selected something like CNO, the column heading was CNO. When we selected CNAME, the column heading was CNAME. It's possible, and sometimes a good idea, to add a more meaningful or descriptive column heading in the result table. This is particularly useful when you're dealing with an interactive query tool and a user has to view the result. We can introduce a rename mechanism called a column alias. This provides a way to change the name in the result table rather than using the name that's inherited. We'll see why this is such a good technique to be aware of in just a moment. Now, a column alias for a specified column is entered in the select clause, the select column list, immediately after the column name. There are no comma separating the table name from the table alias. This is sometimes referred to as column renaming. In this example, the CNAME column will be supplying the values for the second column in the result table, but the name given to this column in the result table will not be CNAME, it will be course name. A couple comments on the syntax here. The as keyword is not strictly required. I believe it's a good idea to use this because it brings immediately to the attention of someone reading the query that you're renaming the column. But it's not a strict requirement. The second part of the syntax is the new name is enclosed within quotation marks, or what a programmer sometimes calls double quotes, in contrast to the single quote or apostrophe. The quotation marks are not required unless there are embedded spaces or special characters other than an underscore. Generally speaking, I think it's good practice to use the quotation marks for the new name. Again, it emphasizes to the reader of the query that there's a renaming of the column in progress. This brings up another point. Notice that the quotation marks are used to give a new name, but the apostrophes are used to supply an actual data value in our predicate here. The value of what we present in the next example may not be immediately obvious to you at this time, but as we move deeper into SQL, its value should become clear to you. Here we're selecting the course number value, the CNO value from a row in a database, the CNAME value from a row in a database, and we are injecting into the third column this character string, this literal, this constant, and this will appear in each row in the results set. So when we run this query, the third column is not coming from the database, but is being kind of manufactured, and its value is inserted within the query process. This query shows that it's possible to incorporate constant data into a column in the result table. As we said, the query retrieves CNO and CNAME values from the database and inserts a value of this character string, expensive, as the third column value. Note that we didn't have to use a character constant. We could have used a numeric constant if it was appropriate for what our objective was. Let's take a look at what happens when we run this query, and we'll suggest an alternative, kind of an improvement on this. Observe the name assigned to the third column in the result table. What the system did was it used the expression that derived the value to generate a column heading for that value. Whenever a query causes a derived value to be placed in the result table, the system will generate a name for the column that contains that value. In later examples, we will see that this is the case when a query includes a call to a built-in function. Thus, the ability to rename a column can be very helpful. This is a good situation to rename the column. Now I'll run the query, and the output of the query will show the new column heading. The name of a table can be used to qualify the name of a column. If we take a look at this query, we see C department is the name of the column and course is the name of the table. The syntax to qualify a column name is simply table name dot column name. Why would we do this? Well, in this example, because we're accessing only a single table and the column names are unique within the table, it's not necessary to qualify the column names. But when we access multiple tables through a join or perhaps subquery type of operations, it will be necessary to qualify the column with the name of the table. This is because some column names are duplicated within other tables. If you look at the column names for the course table, the class table, and the registration table, you'll see all three of these tables have a column named CNO, course number. Class and registration both have a column named SEC, the section number. This is very common in practice. So therefore, when we access multiple tables, it may be necessary to qualify the name of the column. We're showing you one way of doing it here, using the name of the table. Another reason to be aware of this column qualification technique, even when you're dealing with only a single table, is if you're using a program that generates SQL for you. These programs often qualify the name of the column with the name of the table, even if the query involves only one table. The name of a table could also be associated with a table alias. Such an alias is referred to as a correlation variable. Here we're saying the course table is also going to be known only within the duration or scope of this query as simply the letter C. We can use this correlation variable or table alias to qualify the columns in the same way that we could use the table name. So a correlation variable is a temporary variable that lives for the duration of the query that is introduced in the from clause immediately after the name of the table. You would have one or more spaces separating the table name and its associated table alias or correlation variable. And as we said, the purpose for this would be to qualify the names of the columns without having to write out the full name of the table. So instead of saying course.c department, course.credit, we can use this abbreviation. Typically, correlation variables or table aliases are much smaller. They're shorter than using the name of the table. So the name of the variable is arbitrary, but typically in practice it's very short, simply 1 or 2 characters. Finally, we get to the idea of controlling the order of the rows in the results set. If our query does not request that the rows be presented in a specific order, then we have no control over the order in which the rows will be inserted into the result table. The decision is made by the query optimizer. Often, that's not good enough for us. We need to have the rows returned in a very controlled or precise order. So we can do this by using a special clause called order by. This query returns rows from the course table, showing these rows from smallest to largest lab fee value. That is, in an ascending order based on the lab fee values in these rows. So when displaying more than a few rows, this is a good clause to be aware of, because a handful of rows, it may not make a difference for a visual scan. But when we have many rows and we need to be able to examine the result, then imposing an order on those rows with the order by can be very helpful. In terms of syntax, we have the select clause, then the from clause, then the where clause, and we'll see some additional clauses introduced later, but always the last clause that appears in the query, when present, is the order by clause. Now, here we said order by lab fee, and we said that the rows are returned with lab fees going from smallest to largest, ascending sequence. That's the default order. We also can make this explicit by saying order by C lab fee and add ASC for ascending. If we wish to have the rows returned in a descending order, going from highest displayed first down to the lowest displayed last, we could say order by lab fee DESC for descent. In our example here, we're ordering by a numeric column, but we can also use the order by clause to order the result set by character data or date-time data. The order by can also involve more than one column. We could have kind of a primary and secondary, maybe primary, secondary, tertiary, and so forth, column in terms of the ordering. So here we're selecting values from the course table, and our primary sort field will be C department, and the secondary sort field will be C name. Note that we can mix the ordering here. We could actually use the descending and ascending as needed for the specific columns. Furthermore, when we use the order by, we've shown two columns here. In principle, there's no practical limit. The actual limit might be imposed by the resources available on the system, but it's possible to have 3, 4, 5, 6, 7 columns, whatever it takes. Depending on the size of these columns, that might be the limiting factor. So the sort field column names are separated by a comma, the same way we would list the columns in the select list for the columns that we want to appear in our result table. We list the columns to be used for the order by clause, comma separated, and optionally include the ascending or descending keywords. And finally, to summarize what we've talked about here, we say a table reflects a set of rows and columns. When we execute a select statement, we're typically returning a subset of that table, some of the rows, some of the columns. And we give you a couple diagrams here to suggest visually how you might think about this concept of the subset. This concludes our lecture on simple data retrieval. In this lecture, we introduced the SQL select statement and discussed the basic syntax of the statement. We also explained the concept of a predicate and discussed how a predicate could be used within a select statement. The possibility of duplicate rows appearing in the result table was also discussed, along with the means by which we could remove those duplicates if so desired. Finally, we addressed the order of the rows in the result table and explained how that order could be controlled if we wished. In our next video, we'll build on the material that we presented here and more precisely identify the rows that we wish to include in the result set. I know this sounds really exciting, but make sure you're comfortable with the material we've covered here before you go on and view the next lecture.